Hello and welcome to another Asymod video. Today we're going to be going over the new Asymod HPSA V3, the high power standalone asymmetrical hi-fi AM eSSB modulator and station monitor console. In this build we have included a MUX switch that allows you to key up the radio without using a PTT mouse or a PTT mic or a foot pedal. We have included the VFO whine effect, the speaker disable switch so you don't feedback while you're monitoring yourself, and a reprogrammable station ID. You also have an on-air playback recorder that's up to 4 kilohertz of bandwidth. You can adjust it, bring it down to 1.5, 2.5, or 3.5 kilohertz of bandwidth, and this will increase the record time. We have the demodulator section. You can mix your receive or transmit audio to a desired level. You have the TX monitor function that you can choose between the RF demodulated audio or the line-in audio. You have the demodulator tone for the RF demodulator, and you have your monitor level, which is your volume for your monitor. That includes both the RX and TX audio. Then you have your regular Asymod controls, your gain, modulation, carrier, and asymmetry. In the back, you're going to have your ID record function with your ID record button to reprogram your station ID if needed. You have your line-in connector, you have the PTT connector, you have an RF sampler output on a BNC connection. You have the amp keyer, your main high power modulation out, and your HDMI connector for your signal connections. You also have a line out to record your audio into a computer or a standalone recorder. And this unit is a high power unit, so you could drive your PAs and your radio with it. This unit will provide up to 200 watts of audio, and you could drive a radio with an 80 watt PA. Over here you have your indicators when you're in AM mode, when you're on sideband, or your peaks on AM and your on-air light. This HPSA V3 asymmetrical hi-fi AM and eSSB modulator and station monitor allows you to eliminate a lot of the extra gadgets around the radio station, and you have everything in one compact unit. So the demod section is very important because you're able to monitor your transmitted audio exactly how it's projected onto the air. The demod section allows you to monitor yourself and the received signals at the same time. By controlling the mix, you can level it out to where you're comfortable listening to yourself and the incoming stations. And you can monitor the audio via this jack using some headphones. And we'll take a look at the back now. Taking a look at the rear panel, we have our ID recorder audio input, and we have our ID recorder switch over here. Whenever you want to record a new station ID, simply run the audio through this jack while you press this button, and you'll reprogram your station ID. You have your line-in connector from your audio process chain. You have your PTT jack for a foot pedal or a mouse PTT. You have your RF sampler, which allows you to monitor your RF signal and your audio envelope and an oscilloscope without the need to have extra couplers in your RF line. You have your amp keyer to key up your amp with great isolation. And you have your modulation out for the high power stage, RF stage, and you have your HDMI connector for all the other signals between the standalone and the radio. We have a high power TO3 transistor for the output, and here we have our line out, so you can record to a computer or another recorder. And here you have your AC power connector, and of course your ground. The recorder we've installed in this unit is a 4 kilohertz bandwidth recorder. It could record up to 10 seconds at 4 kilohertz of bandwidth. It could be adjusted to record up to 30 seconds, lowering the bandwidth to about 1.5 kilohertz. The station ID also is a 4 kilohertz bandwidth recorder to achieve the best possible audio. The internal power supply is a 24 volt 15 amp supply, and we've installed extra filters to maintain the noise level down. So now let's go ahead and give it a test run. We have installed this unit to go with a Striker SR955, and we've done all the modifications necessary to the Striker, and we're going to give it a test run. Here we have the Striker SR955, and all the connections have been done to it, including the 7-pin power connector for the modulator and the HDMI connector for all the other signals. The radio and standalone unit connection is pretty straightforward. The main two connectors, the HDMI and the 7-pin. We now have installed our line-in connector, our antenna, our external speaker, and our power. So we're getting ready to begin testing, and let's power up the Striker. And let's power up the standalone. We won't be using the standard RF sampler or RF coupler that we normally use and the RF line, because here now we have the RF sampler output right in the BNC connector. Let's get our BNC and plug it in and run it to the oscilloscope right there. We also won't be using a hand mic to key up the radio or a mouse. We're going to be using the MOX, the manual operated transmission button. As a rule of thumb in this unit, we set everything up to make it simple. A standard operation with a 3-watt carrier. You simply put all the controls in the center. Your gain, your carrier, and your asymmetry is the only one that you might want to keep all the way down until all the settings are okay. Then you could add a little bit of asymmetry just to give you some loudness. As you can see, they're all at 12 o'clock. 12 o'clock, 12 o'clock. And that'll give you a 3-watt carrier, about 12 watts PEP, and with a little bit of asymmetry, it could be 16 or 18 or 20 watts, depending on the modulation level that you set. As for here, also the same. And the demod section, your monitor mix in the middle, your demodulated tone in the middle, and your monitor in the middle gives me a comfortable listening level. We'll be running the RA20 mic with Pro Tools, the MBox 2 Mini, to do our tests today. Okay, we'll begin the test. We'll be using Sony Vegas to do the recordings. We're going to be receiving with the IC706, and we're going to be looking at the modulation over here on the oscilloscope, and then we'll check out the VFO line and other things over there in the spectrum analyzer. Now, we won't be needing the PTT on the mic or the mouse, because we'll be using the MOX switch. And right now the station ID is on, so when we transmit, automatically the station's going to ID. We'll start recording here on Vegas, and we'll transmit
Asymod Station ID.
And as you can see, it just did the ID. We'll transmit again.
Asymod Station ID.
Okay, now we're going to go ahead and disable the station ID, and we're going to adjust the transmit side. So we'll bring all the controls counterclockwise, and we'll transmit, and we'll set the dead key for 3 watts right there, and we'll set a reference on the oscilloscope, and we'll go ahead and start the signal generator. As you can see, we already have some modulation in the envelope there. And we'll bring up the modulation, and we'll set it at 12 o'clock there. and we'll bring up the gain a little bit. Right there at 12 o'clock also. And there you have your modulation envelope. It's about 150% modulation right now. And if you want, you can bring up the asymmetry. We'll stop transmitting right now. What we'll do is, since we have the RF sampler, we're gonna go ahead and kill channel 2 and channel 3. We don't need it. We're just gonna activate channel 1, which is our RF sampler from the radio. Let's go ahead and transmit. And there you have it. Modulation envelope. Let's kill the signal generator. Let's set the reference correctly for this. And let's start the signal generator. And there you have your 150. Let's put the trigger to channel 1 now. Okay. So there you have it. That's your RF sampler. Bring your modulation down. Modulation back up. Right there. If you want asymmetry, you give it much more. Okay, so we'll leave it right there, about 150% modulation. We'll take off the signal generator. And now we're gonna do a voice test. We'll start recording now. On Vegas, bring up the volume here till we have a nice envelope there on the record side.
Audio 1, 2, 3, 4. Audio test 1, 2, 3. So this is what it sounds like here running the new Asymod
HPSA. Oh, the striker timed out. It's set to time out after 1 minute, 60 seconds of transmission time. So we'll go ahead and key up.
And we're testing the HPSA V3, Asymmetrical Hi-Fi AM and eSSB Modulator and Station Monitor. So this is what it sounds like. We're going to lift up the mic, the volume. We could raise the volume here a little bit. There we go. And we'll go ahead and bring up the asymmetry just a little bit and test how it sounds with the asymmetry a little higher. There we are, about 200% modulation. And we can see over there on our spectrum analyzer, we got a nice clean signal, no splatter. And that's what it sounds like. Let's go ahead and stop transmitting.
We'll turn on the station ID and transmit.
Asymod Station ID.
Every time we transmit.
Asymod Station ID.
There we go. All right. We'll now test the demodulator, the AM demodulator. So we'll go ahead and delete this here in Vegas, and we'll start off by recording, and we're gonna go ahead and transmit. I'm gonna be monitoring myself on the headphones, and at the same time, the same audio, I'm sending it to the laptop to record the demodulator. And right now, we're already recording, so we'll start transmitting.
Audio 1, 2, 3. Testing 1, 2, 3, 4. This is what it sounds like using the demodulator. And it sounds perfect. Now we can switch and listen to the line in. Audio 1, 2, audio 1, 2, 3. This is the line in coming straight out of the Pro Tools. This is the demodulator. So as you can see, it's working fairly nice. And here, when we stop transmitting, we could hear the radio, but we don't have it on an antenna right now.
So right now we just stopped transmitting, and to hear the radio, just bring the volume up to a comfortable level. And all we have here is FM at the moment. We could hear something on the speaker if I go to the antenna. Go back to AM. But there's absolutely nothing like that. So that's where you can balance here your receiver transmit audio. But for now, we're going to put the volume down. The volume should always be set at 3 o'clock and controlled by here. By the mix control or by the main output of the monitor level. So I'm going to kill the receive audio and go ahead and transmit. We'll put the station ID on.
Station ID.
And that's the station ID.
It's a little too loud. Bring it down just a little bit. This is what it sounds like over the demodulator right there. And it really sounds nice and clean. It sounds amazing. The demodulator is very, it's you can't hardly notice the difference between the demodulator audio and the audio coming directly out of the process chain. We'll switch now from the demod to the line in audio. Audio 1, 2, audio 1. This is the line in audio. This is the demodulated audio. Actually, that level of difference can be set inside. There's separate controls for the receive audio inside, for the demodulator, and for the line in, and they could all be adjusted to where you're comfortable at. The Asymod console has a 15 amp 24 volt power supply. Allows us to generate up to about 200 watts, give or take, of audio power. We could drive 80 watt radio easily. You have the option to drive your final PA of the radio directly with the modulator or the driver stages. And this particular radio, it has a RF linear amplifier in the back, which we're driving directly right now with this. And we're also driving the pre-stages, the final. This radio has a pre-driver, a driver, a final, and then the PA stage. So at this moment, we're driving the radio at the PA stage level and the finals. So finals and PA we're driving right now. It's switchable, so you could just do the pre-driver and the drivers, or the driver and the finals. So there you have it. Asymod console, HPSA V3, asymmetrical hi-fi AM, eSSB modulator, and station monitor.
might follow.